All right, so we're going to go ahead with this review. Before we start, I updated your cheat sheet you're going to get to include this part of your, I guess you could call that also cheat sheet, or this little map you can use. Now, I tried to take everything from the original cheat sheet that we had, this one, and I tried to take this whole table and put it into one nice simplified thing to look at. Now, since I did that, there are pluses and minuses with this. But this is, as you can imagine, I just went through and I color coordinated it. It's up and down. Right, plus is left, minus is right. That seems like it's opposite. I also added, this doesn't happen very often, but if your x is negative, that means it's a reflection across the y-axis. So I also added that just in case. Then the big reason I did this is because I wanted to make sure you realize the C is your vertical stretch compression. The negative has nothing to do with that C. The negative is another transformation that's reflected across the x-axis. Now I added one for the compression. The one on your test will also have that. I added that in there, or I hopefully have. If I haven't, I'll check that. But the only thing on your test is I'm not going to copy it. I'm not going to make the copies in color, so it'll be either a black or a dark gray that is close to black. So I made these in color and cut those out so you guys can use those, hopefully to help out. But again, you'll have that same thing on the test. It just won't be as color coordinated. Now, the other thing I added in here, which doesn't really make much difference, because I told you I don't care what order you do it in, except that there's one question on the test that I do care, and you have one on the practice test that's very similar. We will go over that on Thursday. So, the order you do this in, anything inside these parentheses comes first, then anything out here. So it doesn't matter which one comes first between the C and the negative. That's the second thing you do. And then up and down is the very last thing that you do. So again, you do not have to do these in order. Besides that one on the test, I'm going to try to do them in order just because that's a good habit to get into, and I'm not good at that, so I should try to do that. Downfall, because I did this with x squared. I did not do this with the square root of x. If I did it with x, it would look identical. The h, the k, the negative in front, all of it would look the exact same with a square root. So I thought about making copies where I use the square root, I use the absolute value, and I use the cubic function as well. But all of a sudden, when I do 4 of them, it's starting to look a lot more like this table that I made. And I think that table is because there was a lot going on. Well, that's because I did it for every single one of those parent functions. So let's get started on these this review, and I'm going to go a little bit quickly through this, especially the first part, because I want to make sure we're going to go over this today, and then after we're done, I'm going to hand back your quiz from the other day, and we'll talk about that. So I want to make sure we have time for that. So for this one, if you don't know what to do, you math. So we have a minus back, minus 8 means we're going down 8. Means we're to 2. So this one is left 2. That's all. That. It went to the left 2 and went down 8. I think you guys are pretty familiar with that, but that's where I make sure you start. Because if you don't know that, then the rest of this chapter is not going to go very well. The next one, again, we have a number out front, or sorry, out behind it, so that's going to be up and down. Inside is left and right, so this one goes to the right 4. And up 10. Don't make those harder than they have to be. Now, those aren't too bad, but then some people start missing this when we have a number in front, because that number in front means we're doing a vertical stretch. So the first thing we have is to the left 5. That number in front is a stretch or compression. Notice in here, stretch or compression. And it all depends. If it's bigger than one, it's a stretch. If it's smaller than one, it's a compression. So that one is bigger than one, so it's a vertical stretch. Now, technically, you should say it's a vertical stretch by a factor of 2, but that's kind of a lot to write down. So I tried to simplify it as much as I could, and that's as simple as I can get, because I want to make sure you know it's a vertical. I want to make sure you know it's a stretch and not a compression, and then I want you to know that it's by a unit of 2 or a factor of 2. So I needed that 2 in there. There is to it. Making sure you know that number in front was a vertical stretch. You don't have to do anything else. Just write that down. Now, same thing, number 4 means we go to the right 10. Sorry, make sure you put right 10. And that 2/3 is a vertical compression by 2/3. Now, one thing I want to comment on this one yesterday was how to graph absolute value. This part was the slope of your absolute value. Make sure when you're telling your transformation, don't use the word slope. Say the slope. You can look at it that way. But you can't just say that that's the slope. That's the transformation. Slope of 2/3. Moving on, now number 5 and 6, I'll be honest, the main reason I put these on here is because I wanted to make sure you saw that you have a negative and a number. That means there's 2 different transformations. The -1's transformation, the 3 is the other transformation. So this 3 is a vertical stretch by factor 3. That negative reflects it across the x-axis. And I'm going to reflect x-axis, that's fine, but again, those are the 2 important things. I need to know that it is a reflection, and I need to know that it's the x-axis. Number 6, again, obviously very similar. This one is a vertical compression. Oops. And it is a reflection across the x-axis. Any questions on these? So the other 2, I'm not going to take the time to write these down. And most of the ones I put on the test are only 2 transformations. Usually it's not like 7 and 8 where there's 5 or 6 or 4 or 5. So I'm just going to talk you through these. But again, all you need to do is follow this if you need to. Start inside, then you work your way outside. Oh, sorry. Is it goes to the right 5. Compression by 2/3. And you go up 10. So right 5, vertical compression by 2/3, and up 10. Make sure you know 2/3 is smaller than 1. That's why it's a compression. Number 8, go to the left 7. Factor 2. Reflect it over the x-axis. And down 8. That -8 is down 8. Are there any questions over those? Everybody okay? So one of the things I gathered from some people asking, and maybe it wasn't very many people, but I got enough that I wanted to go over it. They said, where do we even start? So when you do the graphing, where do you even start doing the graph? Well, you want to start with the parent function. Whether you're going to draw the parent function in there, or just put these 5 normal pairs next to them, I don't care. But you're starting with your parent function. I added this on here, and this will be on your chapter test cheat sheet as well. put these dots on here, you can see what ordered pairs I want you to start with. So we're doing a quadratic. This is to the left 2 and 4. So since it is a square, since it has an exponent of 2, that is a quadratic. Hopefully that's a dead giveaway. Hopefully you're good at that. Which means we are using the parent function from our quadratic. So again, copy those ordered pairs on your graph. That's a good way to start. Once you start with your parent function, now you can transformations. Now some of them, like this one, you could do all in one step. I like to do it in 2 steps just to make sure, make it a little easier. So I'm going to go to the left 2. So 1, 2. So 2 is that orange one, and now we're going down 4. So again, everything moves down 4. That is your, oh, sorry, this is a parabola. It should be more U-shaped. I'm not saying that it's like super easy because I know some people struggle with it. But again, all you're doing is you're finding your transformation, and then I'm giving you a starting point that you can actually do that stuff too. Number 10, same absolute value. So my parent function is going to look something like this. To the right 3. So to the right, 1, 2, 3. 1, 2, 3. That's what you end up. Now I'm hoping that this left, right, up, down stuff is getting pretty easy, but we've got a couple more I want to talk about. So this next one's square root. So the square root goes through these ordered pairs. Now again, you don't even have to memorize that. That's on the practice test or on the cheat sheet. And this one goes up 5. So this one ends up looking like something like that. There we go. Number 12, same thing. Now this one, the pair, I only do these 3 dots. There are some other dots you could do. They almost fit on the graph. That's your call. But those 3 are what I'm really checking. And again, this one goes to the right 1 and down 4. Moving to the right 1. It across the X. One here. Sorry. So that's to the left 1. Sorry, left. Now we need to go down world. I'll start over. So we start with the grand function. I move everything to the right one. Down 3. I don't care how you connect those. Just make sure you're including your points, your ordered pairs, especially in your answer. Now, number 13, this is the one. So this is the first one. We have a stretch or compression in here, and it does a little bit. It is a little bit challenging. A lot of people miss these. Horizontal stretch or compression, you're multiplying whatever that number is by your horizontal coordinate. So for this one, this is a parabola. So this is by a factor of 2. So again, what that means is however high your dot is off of the graph, however high that is, whatever that distance is, you're multiplying it by 2 because we have the 2 here. So this one gets multiplied by 8. This one multiplied by 3. Sorry, multiplied 2. 0 times 2, 1 times 2, and again, this one's a little bit off with my stylus, but that should end up 4. 4 times 2 again is 8. So that's off your graph. If it helps you to erase your old points so they're not in the way, you totally can do that. Just be careful. And that is your graph. Again, however much I went up or down, however much I went up, I multiplied by 2. So instead of going up 4, I went up 8. Instead of going up 1, I went 2. Instead of going up 3, I would go 6. Instead of going up 10, you'd go 20. So that's what that 2 gets multiplied by any height or depth if it goes below. Now the next one's the same. It's a little bit harder in the fact that it's just there's a little bit more going on in a small space. Now we're going to multiply all those heights. Now we're multiplying by 1/2. So it doesn't actually matter if it's a stretch or compression for the graphing part. You do it the same. So instead of going up 4, I only go half that much. Instead of going up 1, I only go half. 0, 0, half, and so that that red graph would be your answer roughly. Again, you multiply everything by 1/2. So instead of going up 4, I went up. Instead of going up 1, I went up 1/2. Vertical compression. Now, again, in my opinion, those are more difficult than the ones we just translations up, down, left, right. But it's still not too bad. You just have to make sure you know what they're asking for and go slowly with that. And the last ones we have are the reflections. A square root. Our parent function. Points across the x-axis. Now again, if you can't tell, I said if there's a negative, look where it's at. If it's in front, it is across the x-axis. So please keep that in mind. Keep that hand if you need to. Across that axis. One step away. One step. That is what your new absolute value should look like. The blue one, not the red one. The next one is a square root. Now this is reflected. We'll across the y-axis again, same thing as before. This one's 1 step away, so this one's 1 step. This one is 4 steps, and this one is 4 steps. That is your graph. Again, it looks almost like identical. The only difference is it's pointing the other direction. Any questions so far? Now, the only other ones I added, number 17 is make sure I drill into your head. 3 are 2 different transformations. Doesn't matter which one you do first. So with an absolute value, you have these ordered pairs. Now I'm gonna multiply them all by 3 first. So everything I'm gonna go up by 3. So instead of going up 2 times 3 is 6. 0 times 3 is 0. Whoops. And make sure it is somewhat of a V shape. We're not done yet. That was close. So I just multiplied everything. I stretched it, but now I need to reflect it. Again, just make sure it's on the same. This one is up 1, 2, 3, 4, 5, 6. So we need one down. 1, 2, 3, 4, 5, 6. The next one's down 2, so we have down 2, down 2. That is your parabola. So again, don't be confused if it opens up or down. Just do what it says and go slowly. Now the last one, I'm not going to go a little bit of time, but also you guys could do this. Time, it'll take a while, but you can start with your pivot function. Start with our pivot function. Then just go through. We are moving it to the left. The 2 in front is a vertical stretch. Hard to make sure you across the 4 is up 4. So again, you could do that with each one of these. Go to the left 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Then you could stretch that by a factor of 2. I didn't put that 2 in there. But you could do that. Or I guess I should say you should be able to do that after this review.